So you should have just watched the video where a guy used a string to create an ellipse by drawing it and using the string to hold, and it had like two kind of spots where the string was attached. He had some, I think he had some like toothpicks or something stuck in a paper or something like that. But anyway, so you should remember back to parabolas, and parabolas had this thing called a focus. Well, an ellipse has a focus as well, and actually, every ellipse has two foci. Well, almost every ellipse. Every ellipse has two foci, and those foci are where, and some people say foci, some people say foci, some people say foci. I just say foci. I don't really know what's right. Anyway, I just care where they are. So I can find them, and they are those spots where those toothpicks were in that case, and they kind of show up in lots of different like word problems and applications and stuff like that of ellipses, and we like to use those problems on tests and stuff like that. So before I talk about how to find the foci, it's pretty easy. I want to talk about, I think that you should be comfortable with this. This is one of the examples that we did earlier. And we graphed it like this. But I want to name these spots a little bit more. So I'm going to use some letters. A is the longer axis on, I'm just going to call it E, on the ellipse, which in this case is equal to 5. It's this length right here. We call it the major axis. And then this coordinate right here, 5, 0, is called a vertex, as is this right here. So I'll just label this as V, and this as V for vertex. So I'll put in parentheses, that's where V is. Next thing is B, and B, you probably guess, is going to be the shorter length. So I got these guys. So B is, shorter axis on the ellipse, which in this case is 3. Now we don't want to call it a vertex because the vertex is already taken, so what we do is we call it a covertex. So I'm just going to label this CV and this CV. So, for example, if I were to tell you where the vertex and the covertex and maybe the center or some combination of those guys, where you should be able to get to the equation. The last length that I'm going to call or use is C. And C is going to be the distance from, or length, to the focus, to either one of the foci, from the center. So it's kind of like the p-value or the a-value, or however we talked about it when we were doing, what do you call it, parabolas. So there's a nice little formula that relates A, B, and C. And it looks almost just like Pythagorean theorem. So what it is, it's c squared equals a squared minus b squared. So it's almost exactly the same as Pythagorean theorem, except for we have a minus sign right here. Just want to point out that that's when we have a plus here. So we're going to change some things with one more shape we're going to do, and you'll see those changes next time around. So let me scroll down a little bit. Let me go to here. So I'm going to do the work to, I'm going to do the work to figure out what C is. So longer axis is A. So A is root of this number, so A is 5. So C squared, I'm looking for C, is 5 squared minus, now the shorter axis length, which is 3, which is this guy, which comes from the root of this number, is B. So minus B squared, so minus 3, minus 3 squared. That gives me that C squared is equal to 25 minus 9. Come over here, that gives me that c squared is equal to 16. Root both sides, I get c is equal to 4. Is that right? Yeah. So what I'm going to do now is go, the foci aren't going to be outside of the ellipse. That wouldn't make sense. It wouldn't make sense for them to be up and down 4 here, because you should have seen how in that video the guy who made it, like those toothpicks were inside of his ellipse. So instead we're going to go out 4 this way and out 4 this way. So I'm going to go out to here and label that as F, and then I'm going to go out to here and label that as F. So with all that information, you should be totally set to work through all the problems that we want you to do in your book. Sometimes, we give you information about an ellipse, and maybe I say that the y-intercepts are these guys, and that's going to help you find either the A or the B. One thing you want to be careful about, actually, I'll give a little bit more space. So we haven't talked about ellipses, that are that start somewhere other than the origin, that have center other than the origin. But we get the same properties for this as we got for the other shapes that we've done. So if I have x minus h squared over a squared plus y minus k squared over b squared equals 1, then that's going to be the form of an ellipse. In this case, if that's an A and this thing is bigger than this guy, then it would be side to side. If I were to switch these two and this one was bigger than that one, it would be up and down. But same thing, the center is the value of x that makes me square 0 here. So if h was 10, then it would be the center would be over to the right 10. And if k was 3, then the center would be up 3. So we're going to use those same properties right there to move them side to side and up and down. So now you should be set to do the different types of problems that we're asking you to do.